we're working with congruent triangles. Here we're going to be comparing the first triangle and the second triangle here to determine why they are congruent. Okay, using the theorem of the side-side-side congruent triangle theorem. What does the side-side-side congruent triangle theorem means? It means that if there are three corresponding congruent sides on both triangles, then the triangles are congruent. Okay, so here we're going to be comparing the two triangles in the first question. We're going to be comparing segments. AB is going to be congruent to segments DE. How do we know that they're congruent? Because they're both given the measurement of 6. Okay. So now here the next two sides that are congruent is segment BC is congruent to segment EF. Yeah. BC is congruent to EF on triangle 1, and then EF in triangle number 2. And then the last side is the hypotenuse, which is AC. Segment AC is congruent to segment EF on the second triangle, which has a value of 8. We can say that they're congruent. We can make that statement. Since we know that side 1 is congruent, we have a second side that is also congruent, and we have a third side that is also congruent. Then we can make a conclusion, right? Our conclusion is that triangle ABC is congruent to triangle DEF. How do you know they're congruent? Okay, once again, we're going to be using the side-side-side congruent triangle theorem. Do we have at least 3 corresponding congruent sides on both triangles? Let's try to see. Go back here. Yes, we do. We have side 1, side 2, and side 3. They are corresponding. AB is corresponding to DE, BC is corresponding to DF, and AC is corresponding to DF. Okay. So we have 3 sides that are congruent on both sides of the triangles. Then we can conclude that the triangles are congruent. So here I can make it based on the theorem here. If I know that there's 3 corresponding congruent sides on both triangles, then I conclude that both triangles are congruent. Okay. Using our reasoning here is using the side congruent triangle theorem. Okay, and that's pretty much it. The second example here on the right here is not really any different, right? So here you're given measurements. This is 4, they give you a measurement of 6, they give you a measurement of 8. This one here, they give you an indicator or a label that states that AB is congruent to DE using tick mark. What does tick mark mean? Tick mark indicates that they are congruent. We're just saying that AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. Kind of the same statement we're going to be making, right? But it's just the way it's represented is different. Here it's represented by numbers given. Here you have congruent sides represented by tick marks. Okay, the number of tick marks represents which side they are congruent to. This is 1 tick mark, so BC would be congruent to 1 tick mark here on the second triangle, which is EF, and so on. 2 tick marks is going to be congruent to this other tick mark, and a third 3 tick marks will be congruent to the other side that has 3 tick marks. Okay. So just a background knowledge of that. So here you're going to have the second question here. We're going to be given questions like this here, where you have 2 triangles that are combined together, which is kind of confusing sometimes, right? So what you can do is you can separate the 2 triangles. Okay. So here you can separate the 2 triangles. Here you can separate it, and then you can just write down the statements, right? Here we're going to write down the statement that BY, the first side, or first corresponding side is congruent with BY is congruent to the other tick mark, which is WZ, sorry, and side number 2. Sides number 2 that are congruent is BW, congruent to YZ, because you only have one tick mark. And side number 3 is kind of tricky. I kind of already put it here. How do we know that WY is congruent to WY, right? If you look at the diagram here, what happens? They share the same side, right? Let's just say an example, I gave it the value of 10, right? If I gave this value of 10, then I know that WY has the value of 10. And the other side here also has the segment of WY, which will also have the value of 10. That means that WY will be congruent to itself, which is also WY. Okay. So that is, we can state that as a third statement, WY is congruent to WY. And just for the students that are confused, how did I get 10? I don't have the value of 10. I just use that as an example. Okay. So my students think I'm just pumping out numbers and they're going to ask, how did I get it? So I'll just clarify that. Here, once again, the third side here are congruent Y because they share the same side in this diagram. WY is congruent to itself. Okay. And the reasoning for this is using we never covered it, but I'll cover it now. It's the reflexive property of congruency. Okay. So now we have one side that is congruent, WY and WZ. We have another side that's congruent, WW and YZ. And we also have the third one, which is the hypotenuse, which is the WY is congruent to WY. How they congruent? Because they are the same exact segment. So it is congruent to itself. Since we know that you have 3 corresponding congruent sides, then you can make a conclusion. We make a conclusion that triangle BWY is congruent to triangle WYZ. Okay. Using what theorem? We're going to be using the theorem of the side congruent triangle theorem. Note that you can always, you don't like the word, you don't want to keep writing the word congruent, you can just use a symbol like this to replace it if you feel more comfortable that way. Okay. Side congruent triangle theorem. Okay. Hope that makes sense.